It's your friendly math tutor, Miss C here, and today we are solving exponential equations. Our first equation is 3 to the power of x is approximately equal to 237.72. The first thing I notice is that our variable x is an exponent. That tells me right away that I am going to need to use logarithms to solve this equation because exponential functions and logarithmic functions are inverses of one another, and I'm trying to find an unknown exponent. So what I'm going to first notice is that all I have on the left side of my equation is my base of 3 that's raised to a power x. On the other side, I have what 3 to the power of x equals, and that's all. So what that means is I'm ready to go ahead and use a logarithm. So always, I have to have the base and the exponent on one side and everything else on the other side to be able to use logs in terms of order of operations. So I'm also noticing this is base 3, which means that I have to use the change of base property to figure this value out. So I'm going to start by saying x is going to be equal. So my exponent is equal to the log of the non-base. So my non-base is 237.72 divided by the log of my base, which is 3. All right, when I put that into my calculator, I get x equals 4.98. And actually, let's be clear here. This is approximately equal, both of these, because we've rounded our decimals here. Okay, quick tip. In your calculator, when you go ahead and do this, you're going to notice your calculator automatically puts a parenthesis right after the log. You have to close that parenthesis here before you take the next log. Otherwise, your calculator thinks that log of 3 is inside of the log you've just taken, and you're going to get the wrong answer. Now, to double check that your answer is correct, all you do is you pop 4.98 into x in our main equation. So I'm going back up here and plugging it in. And when I put that into my calculator, I get 237.72 approximately. Let's try. Our second equation is a little different than the one we just solved. You're going to notice we have an unknown exponent still, but inside that unknown exponent is a plus 4. So it's x plus 4. So the good news is we solved this in the same way that we solved the last equation. We just have one additional step. So I'm going to notice that once again, my variable is in the exponent, which triggers me to think that I have to use a logarithm. I'm noticing that my base and my exponent are the only thing on one side of the equation. That means I'm ready to solve. And my base is not 10, so I have to use the change of base property since my base is 1.28. So I'm going to start by saying that my exponent, which is x plus 4, so that's the entire exponent, not just the variable, is equal to the log of the non-base. And I'm going to go ahead and put my parentheses in here, just like I will be doing in my calculator. And I'm dividing this by the log of my base, which is 1.28. All right, remember, this is our non-base, and 1.28 is the base of our exponent. Okay, all right, when I go ahead and put that into my calculator, I end up getting about 7. Kind of rounds off pretty nice. And now my last step is to isolate x. I'm going to do that by subtracting 4 from both sides. When I do that, I end up with x equals 3. So to check my answer, I'm going to plug 3 in for x in my original equation. Here comes 3 right here, plus 4. Okay, when I do that and simplify, I get 1.28 to the 7th, and that is approximately equal to 5.63. And you know what? I'm getting a little sloppy. These should be approximately equals all around here because we've rounded our numbers. All right, let's try another. Problem 3. So I'm noticing once again my exponent is my variable, so x here. And I have 4.9 to the power of x minus 150 is approximately equal to 170.19. So little different than what we've seen. We've got something being subtracted. So my first task, anytime I'm trying to isolate a variable, right, is to get the term that contains the variable on its own side. So there's nothing different here, even though our variable is an exponent. So I'm going to go ahead and add 150 to both sides. And when I do that, I'm left with 4.9 to the power of x equals 320.19. The good news here, this is exactly the form I need my equation in order to use the logarithmic change of base property. So remember, 4.9 is my base, 320.19 is my non-base. So I'm going to go ahead and let my exponent, x, be equal to the log of my non-base, which is 320.19, divided by the log of my base. Just a friendly reminder, when you go to pop this into your calculator, you need parentheses around the entire value in the numerator. Otherwise, you're going to land on the wrong answer when you put it into your calculator. All right, when I do this, I get approximately 3.63 as my solution. You should go ahead and plug that back into your calculator. And when you do that, you're going to find that you've solved this correctly because you get approximately 170.19 out after you check your answer. Let's try another. Next problem. So similar to what we've done in the past, we've got a variable exponent, but we also have 28 being multiplied by the base. So what we cannot do is we cannot multiply 28 by 0.88 because that 0.88 is locked in to that exponent. The 0.88 is the base, the 28 is not. So they can't be combined. All that to say, our first step is to isolate the 0.88 to the power of x. So we're getting the base and the exponent by itself like we always do. And we're going to do that by dividing by 28 on both sides. So when I do that, that leaves me with 0.88x is approximately equal to 28.147 divided by 28. I am making a very deliberate choice not to write this as a decimal, or like to divide this out and write it as a decimal, because I can already tell that my answer is rounded off here because it's approximately equal to. The more I keep rounding, the more inaccurate my answer is going to be. So I'm just going to leave this whole chunk right here as my non-base and work with it from there. And that way we get the most accurate answer. So we have our base and our exponent on one side, everything else is on the other. It's time to use the change of base property. Remember, we're doing that because 0.88 is our base, not 10. So I start by saying my exponent, which is x, is equal to the log of the non-base, which is 28.147 divided by 28. So remember, we pop that into parentheses in our calculator, and then we divide it by the log of our base, which is 0.88. And when we put this into our calculator, we get x equals negative 0.04. Now, I went ahead and substituted this back into the equation, and this is in fact the correct answer. So there you go. Pretty easy, following the same pattern. Let's do a couple more. They're going to gradually get harder. All right, our next problem, we're combining a couple things that we've already learned. I noticed that I have my base multiplied by 15. I also noticed that my exponent isn't just the variable, it's 2 times x. So we're going to practice that again. So our first thing that we need to do is we need to get 1.45 to the power of 2x by itself. Remember, we can't multiply 15 by 1.45 because the only thing being raised to the power of 2x is 1.45. That locks it in, so it's not combinable with anything. So I'm going to divide by 15 on both sides as a result. And just like I did in the last problem, I am going to not calculate out this right side. Oops. because I want this to be as accurate as possible because it's already been rounded. That's what that approximately equal to means. Great news, we now have our base and its exponent on one side and everything else on the other side. That means we're ready to do the change of base property because our base is 1.45 and not 10. So we start by saying our exponent. So our exponent is 2x. So our exponent equals the log of our non-base, all right, which is 616.27 divided by 15, all divided by the log of 1.45. So when we go ahead and put this into the calculator, we get 2x equals about 10, right? And actually, this should have been about equal to 2. I'm not being very good about that in this video. All right, so we have 2x is approximately equal to 10. We need to get x by itself, so we're dividing by 2. So x equals 5. So when you check your answer, you're popping 5 in for x. You can just put this straight away into your calculator. I checked our answer. This checks out. We get approximately 616.27. All right, on to the last problem in this video. All right, we have definitely saved the best for last here. We have a longer equation than we've seen to date. So all the things we've learned, we've got something added, we've got something multiplied to our base. So let's just make sure that we all see that we have an exponent that includes a variable. In this case, it's x minus 5. Remember, the only thing that is being raised to the x minus 5 power is 0.64. So our goal is to get 0.64 to the power of x minus 5 on its own side. That means we have to get everything else to the other side. So we are following the order of operations backwards. So we are starting, and in case you don't know, that's because we're solving an equation. If we follow PEMDAS from P to S, we're simplifying an expression. When we follow it from S to P, that's backwards, we're solving an equation. So here we go. We're starting with any addition or subtraction. So I'm noticing that 81 is being added to this side. To remove it, I'm going to use the inverse of addition, which is subtraction. That gives me a big old 0 here, and I'm left with 49 times 0.64 to the power of x minus 5 equals 2.155. And I should not say equals. I should say approximately equals because this has already been rounded. Okay, now I need to get rid of the 49. So I'm going to divide both sides by 49. In order of operations, it says that we're doing multiplication and division next from left to right. 49 is being multiplied, doing the inverse of that, which is dividing. When I do that, I get 0.64 to the power of x minus 5 is approximately equal to, I'm leaving this as a fraction because it's already rounded and I don't want to round it anymore. This is the most accurate way to solve. All right. Now, great news. I've got my base and my exponent on one side and everything else has already been moved to the other side. So that means I'm ready to utilize logarithms. So we are going to start by saying that my exponent, this whole thing, x minus 5, is equal to the log of the non-base. So that's this. So the log of 2.155 divided by 49, right, is divided by the log of my base, which is 0.64. And you guys, I did it again. I used an equal sign out of habit. This is approximately equal. Okay, when I go ahead and put this into my calculator, I get x minus 5 is approximately equal to 7. All right, now all I need to do as a last step is to get x by itself. So to do that, I'm going to add 5 to both sides, right? I'm doing the opposite of subtraction. That gives me a 0. That's my goal. And then I get x is approximately equal to 12. So when I go to check my answer, I'm popping 12 back in here for x, right? And I already checked our answer. When I do that, I get 83.155 approximately. out as my solution. All right, I hope this video was helpful for you in solving all sorts of exponential equations that require the use of logarithms. Make sure to subscribe for more math videos. Till next time, remember, you've got this.